Okay, everybody. So this is I guess the week 16 lecture, we'll call it. I recorded another lecture in week 16 already, but I called it week 15 lecture 2 for some reason when I posted it. So this is the last lecture. So what are we doing in this lecture? We are just going to try to finish up the week 15 books here. So where we were last time was we had done some of it. I think we got right up to where we started the stuff that has to do with files. Come on, you can load. I have faith in you. There we go. Okay, so we had done, looking at 15, output formatting, and we were about to start streams using strings. So this is still like walking or working up to using files. So this stuff was not really in the lecture video, but we can, go through this relatively quickly here, hopefully. So it says programmer can read data from strings instead of from the keyboard. Okay. And then it shows you how to do that. And so what it shows you how to do, as it shows right here, is it says scanner in SS. So that's just a variable name equals new scanner user info. And if you look here, you see that user info is actually a string. And so if I open up Eclipse just to demonstrate, um, come on, open up Eclipse. And I'll just create an assignment, call it what? We'll call it stream example. We'll go ahead and add class there, and we'll call this stream example again. Check the box. Okay, so what can we do? Well, we'll need scanner, so import java.util.scanner. And then in here, let me just, as an example, we'll just do string, my string, and what will I put in here? I'm going to put my name, and then I'm just going to put a number here. Uh, in the honor of the season, we'll put 67. Now, so this is just a string. Now, if I create a scanner, I can go scanner, what do we want to call it? I'll call it stnr equals new scanner. And instead of putting system in here, we can put my string like so. Save that. And it's going to complain that it's not closed, but that's all. So now I can do this. So what if I do this? String my first name, and we can get my first name from this string because I can do my string dot next, right? Doesn't next, we've learned get the next word. So if you read one word from here, you're going to get Greg. And if I do the same thing but last, then yeah, that's the next word is my last name. And then if we do an integer, so get rid of the string here, int number, and we can do my string dot next, and we can do next int. And so if I run this, let's see what happens. Errors exist. What are my errors? Oh, I put my string everywhere, but this should have been the scanner. I don't know why I did that, but once I did it wrong once, I just didn't think about it again. So we'll use the scanner to read those. So when we run this now, we don't see anything here in the output because we didn't print anything to the screen, but we can do system.out.println. And if I print my first name, what will appear down here? Right? We do get my first name. So using the scanner that we made from the string successfully retrieves that first word. And if I do last name, and if we do the number, then you can see all of that information was retrieved successfully from that string. So that's what they're doing here is they are having a string with some data in it. Actually, it looks like they did pretty much exactly what I did, right? They have a first name, a last name, and a number, and then they do first name, last name, and the number. Um, and this is the scanner that they called NSS, which was a scanner where instead of putting system.in, they put the name of a string which had previously been declared. So let's see. An input string stream is used to read data from what? Well, I guess from a string because it's called input string stream. Which statement initializes the scanner object to create an input string stream using the string variable input line. So if the string is input line, that's what goes inside here. So must be the middle one, which statement extracts the next string before white space. So we know that next line reads a whole line, next int reads one int, and next reads one word. So they said one word up here because it says before white space. So that's a word. All right. So what are they doing here? Process a line of input text. So this is an example of what you could do with this. So you could say, for example, I could tell the user system.out.println or print, I guess. I could say type first, last number like that. And then I can, instead of having my string being read in this way, I could read that in with a scanner. But I don't have a scanner, so I better make a scanner up here. Scanner, I'll say key scanner, key SCNR, because we've already got another one, right? So new scanner dot system, can't write, new scanner system dot in. So that's not what we normally call our scanner, but that's what we're calling it here. And then I could do my string, instead of having my string here, I could get it with key SCNR dot next line. So you see what I'm doing is exactly the same thing we did before, but instead of having the string typed out here with my name, I can type my name in at the prompt. So when I run this and it says, oh, we got errors to fix. What's the error? Oh, no semicolon. Try it again. So it says type first last number. I mean, that was what I put in the prompt. So I could say, uh, my name is John Montoya. Who's that? It's one of our math faculty. Why? Because I saw him earlier today. Number, there's a number, right? And so you can type in one line, and then using that other scanner, we separated that out into three separate variables using the scanner called SCNR. So I had a scanner called key SCNR that was set up for the keyboard. I used that to read in a line of text. Then I set up another scanner, but this scanner was set up for the string. And then I used that scanner to separate out the words that were in that original string. So, okay. So they're doing that here. So somebody typed Mary Jones 22 and they separated out. Somebody typed in Mike Smith 24 and they separated that out. The end. Um, so we can answer some questions about this, but I need to get down to some more important exercises. So in the code example, which control structure is used to continue reading until the input is done? You can see that they put this whole thing in a while loop. So the loop just keeps looping until you type in the word exit. So they used a while loop for that. Which scanner method is used to read and store each line of input? So there's going to be two scanners here. You see that they've got a scanner called SCNR and they have a scanner called NSS. And looking carefully, you can see that SCNR is the one that's made from system in, which is the keyboard. And in SS, you'll see somewhere down here, in SS is a new scanner made from the string. So you typed in a string and then we basically attached that to a scanner. So the question down here is which scanner is used to read and store the keyboard input? Um, Actually, which scanner method is used to read and store each line of input? So the line of input is being read right here. SCNR dot next line. Um, yeah, I don't know what I was looking at there, but next line reads a line, next reads a word, and next str doesn't exist. All right. Now then we get into output string streams, which is how to print to a string. So you can create a string writer and then you can create a print writer. And so it's like a two-step process, just like when we do files. And so you create a string writer. After you create a string writer, this one was called age stream. They put age stream into the print writer, and now they have a print writer. And what you should remember from the lecture on writing to files, you should remember that the print writer was where the methods like print, print line, and printf live. So later on here, you're going to see age OSS being used, like age OSS dot print is going to be used. Age OSS dot println is going to be used, right? And so you see here, for example, age OSS dot print minor, and down here, though this one's system dot out println. So this one's printing to the string, this one's printing to the line. So what that allows us to do is you can print a bunch of stuff to a string, basically get the string ready, and then you can do what you want with the string, which, print it out to the file or print it to the console or print it somewhere. Um, Scrolling down here, let's try to get to some exercises. Declare and initialize a print writer variable. So they said it was a print writer variable, right? So we know that you should start out just with the type, print writer. And then the name, you can see they said to call it out SS. And then when you're declaring a class like this, we're pretty used to at this point typing things like new print writer, like so. And then what goes in there? Well, the name of a stream. So the reason they gave you this line up here was so that you could copy simple stream into there. All right. Write a statement that copies the contents of an output string stream to an existing string variable called myString. Assume the string writer and the print writer variables are called simple stream and outss. So that's a little bit complicated, but that's where you kind of want to look at an example. So when you scroll up here, um, so there's a string writer called age stream. Okay. There's a print writer called age OSS. And when you look down here, the one that's used for printing is the one that's called age OSS, right? And age OSS was a print writer. So when you scroll down to the exercise here, and it says the string is called myString, the string writer and the print writer are called simple stream and out OSS. So out, I said out OSS, but out SS that's the print writer. So that's the one that you can print to. So it says the contents of an output string stream. I don't know how much it wants here. Like I can't tell if it wants just one line or if it wants like three lines to do this all. Um, yeah, I'm not going to answer this. Um, so, okay. The string writer's toString method returns a copy of the string in the output string stream buffer. Um, okay. I guess they would have told us that up here somewhere. Maybe they don't. I'm not sure. But regardless, let's do the challenge activities. So, challenge activity. We're writing the output. So, let's see what happens. So, we got a bunch of scanners and streams and things here. And I just want something to type into. So, I'm going to open text edit, which it's not really what I wanted. A new file. All right. So, let's just make everything big. All right, cool. So, what are we doing? So down here, we see item info is a string with some data there, and item ISS is a scanner made from item info. So just kind of notes for myself here. Item ISS was made from item info, which contained headphones 1811, right? So item ISS is a scanner. I should say that is a scanner made from item info, which is headphones 1811. Okay. So with that in mind, when you do item ISS next, so item ISS dot next, we know that next reads one word. So item ISS dot next reads one word from what? Well, it reads one word from wherever the scanner reads from, but the scanner was made from this text here, right? Headphones 1811. So if you read one word from here, you're going to read the word headphones. So when you do this, it's going to read the first word from the string. So specifically, item is now going to be headphones. Okay. And then price equals items ISS next int. So that's going to read a number from here. So it's going to read the 18. So it's going to read that the price is going to be 18. And then the next thing that's read is quantity. So the quantity is going to be 11. Okay. And then after that's all done, headphones 1811, then it prints them out this way, which is item. So the item was headphones, and then it says plus a space and an X, so plus X. And then after that, you get the quantity. The quantity was 11, right? Quantity was 11. So you get headphones times 11. And that was a print line. So you go down to the next line and it says price. So you go price, colon, space, and then price, which was 18. And this does not have a new line on the end of it because it's just print. So I guess we're done. And we got it. So skip to the third one. So for the third one, this is going to be the same kind of setup. No, it's going to be a little bit different. So we're writing to a string here. So we've got item OSS is a print writer. So that's allowing us to put stuff into a string. that was made from um, item character stream. Okay. All right. Then what? So then they're printing here. So they call item OSS dot print line, right, to print. To print what? What do they print? So they print item X quantity, and they have the item, the quantity, and the discount here. So what they try to print is the item, which is shoes. So shoes space X quantity, which is 16. That's in a print line. So then we'll go down, and then it prints the discount, which is 20, 20, and then percent symbol, and then space off. And that was a print. So this is the string here that they've created. Okay, so that's in the string writer, or actually that's in the print writer. So we printed this all to a string, but then um, they do item character stream to string. And so this right here is what actually turns this stuff that's just in memory somewhere into a string. So when you try to do system.out_print this, you're going to get this. So this is what we get. Okay. So we got a couple to do here. All right. So let's pick up the pace a little bit. So what's it say? Write code that uses the input string stream in SS to read input data from string and update the variables, blah, blah, blah. Okay. So what are we doing? um, so the user types in this, which is in SS. So we have to set these up. So we're going to have to set up a scanner for, actually, they've created a scanner called NSS, but they haven't set it up for the string. So we have to do NSS dot, and we have to basically initialize this. So I don't know why I wrote dot. NSS equals new scanner. And we want to make this scanner from the string. What string? It must be the user input string because they're typing this in. So they're typing on line 12, they're typing in January 12th, 1992, and that's the stuff that we need. So we have to create a new scanner from that input, which was user input. Okay. So that will allow us to like get data out of the user input string. Not typing that very well, but that will allow us to do that. Okay. Now, once we've done that, specifically, we need to get the month and the date and the user year from that. So we basically need to do user month equals something, user date equals something, user year equals something. And we're going to use this scanner that we just made to get those. So they're all going to be in SS dot something. And these are scanners, so we use scanner methods. So if you wanted to get the month, which is January or just Jan, that's one word. So that's one word. So we would use next to read one word. And the user date is 12. So that's the next thing. But what type is it? Looking up here, we see that the user date is an int. So we don't want to do NSS dot next because that will read a word. We want to read the 12 as the number 12. So that is a next int. And then the year is also an int. So we're going to read another int. for the year. So once the scanner is created, we can get a word and two numbers out of that string. And after we do that, they're going to be printed out down here. And we got it. So that was the entire, there wasn't like a 5-part thing there, just one part, thankfully. Let's come down here. Write code that inserts user item into the output. Um, okay, so they type red, purple, yellow, exit. Um, okay, so they've got a loop here while the user item dot equals user item dot equals exit, but then they have not. So while it does not equal exit. And then down here, they have user item equals scnr dot next. So this is going to read words into somewhere. Where? What's user item? User item's just a string, right? Yeah, user item's just a string. We're reading a string in here. And then what are we supposed to do with that string? So they type in red and then they type in purple. Well, they type in red, purple, yellow, exit, but we need to read that like one word at a time, I guess. And we've got it one word at a time because the user item equals scnr next is one word. All right, what are we doing with those words? Okay, so we have the word. What do we do with it? So write code that inserts user item into the output string stream. So the output string stream is here, item character stream, but it was made with a print writer. So, or not made with a print writer, we made a print writer from it. So in order to put something into this character stream, we print to it with items OSS. So we do items OSS dot, and to print, you just do print. And then what do we need to print? Well, it says code that inserts user item into the output string. So we want to put user item in here. And then it says each item should be followed by a space. So user item, and then we can do plus and a space. So this will print to items OSS, which is a print writer, and items OSS was made from items character stream, which is the string writer, which is, I think, what it asked us to do. So this is how we print using the print writer that they gave us. If we get this wrong, we'll fix it, but we didn't. Seems fine. Okay. So all of that was kind of preliminary. It's a little bit confusing, like the print writer versus the string writer versus etc. But this section at least should match up with the lab and it should match up with the lecture. So um, just to kind of remind ourselves, we might need to go back here, click home. Just to remind ourselves, there's some lecture slides here that are probably useful for this. And that are going to help us read and write files. So what are we doing here? We are reading from a file, reading from a file. So to read from a file, that's what we did first here in the notes. So we're going to need an input stream and a scanner and also this IO exception. And so you'll see that here, right? The input stream, the scanner, and the IO exception. You'll see that they had to add this throws IO exception here. Then after you do that, if we look at kind of a minimal example, I'm just scrolling through, then after you have those there, you put the throws IO exception. In order to write to a file, you set up a file input stream and then a scanner. After you do that, you can read from the file as if you were reading from the keyboard. So you can do like scanner.next, for example, right? Now I'm going to skip through this like what did they do wrong here? Let's see. So we can compare to a working example. So they created a file input stream, just like we did here, yellow. They created a scanner in FS, just like we created a scanner in FS here. They've got some other variables that we don't care about at the moment. Then they did NFS equals new scanner FB stream. So that FB stream was a file input stream. Just like the scanner here was what's called FIS, which was a file input stream. So that all seems fine. And then they did num equals new int num elements, which was 0. Um, oh, sorry. They did this, and then after they set that up, then they did num elements equals NFS dot next int. So that's going to read one number from the keyboard, or actually from the file. Oh, okay. So looking at this a little bit more carefully here, right? In my example, file input stream, you create the file input stream from a file name, right? Which in my case was example.txt. And then after you create the file input stream, then you can do the scanner from the file input stream. But the point is the file input stream has to have the file name. And here, file input stream, FB stream, where did they ever do the equivalent of this top line here, the top yellow line, with file input stream equals new file input stream? They didn't do that part, right? That's missing. So it says the file stream is not big enough. No, the file stream has not been properly opened, right? They didn't have a file name or anything. Okay. Which statement opens a file input file? Well, equivalent to here, right? File input stream, FIS equals, you're looking for a new file input stream, and then a file name goes inside it. So we're looking for new file input stream, and then a file name goes inside it. So like this bottom line. Okay. Now we also learned in order to read from a file until the end to use a while loop like this, where you check if there's more to read. So I think I had NFS dot has next, not has next int, but it's the same idea. So let's go find some exercises that are a little um, more to do. And oh, look, we got multiple files here. Cool. Awesome. All right. So this is 15.4.1. Declare the following variables. Oh, okay. So we're doing the equivalent of these two yellow lines. That's it. So it says declare the file input stream variable named fbyte stream is initialized with null. Okay. So they're specifically told us to do this. So it says file input stream variable named fbyte stream. So I'll just copy paste that. And they say, and initialize it with null. So here, like if you know the file name, you go ahead and put it in. If you don't, you can just type null, and that's just basically the name exists, fbyte stream, but we haven't, actually made the variable functional yet. And then it says the scanner variable, so okay, scanner named data fs equals, that's also initialized with null. Okay. Well, that's all they told us to do. So, I mean, I guess that's all they told us to do. Okay. Let's do the next one. Okay. Now it says assign file byte stream. Okay, so assign file byte stream. So that's file byte stream equals with a file input stream. So that's new file input stream. And what goes inside there? Well, what goes inside new file input stream is a file name. So they must be giving us a file name. And it says that opens the file letter file name. So that's they're getting that from a variable, but letter file name is where the file name is. All right. Then it says assign NFS. So that's NFS equals with a scanner. So that's new scanner created using file byte stream. So that's file byte stream in there. So they're just making us declare these variables and put the right things inside them. So like you saw here, after you create the file input stream, mine was called FIS, then FIS is what goes in the scanner. So they called theirs file byte stream, so file byte stream is what goes in the scanner on the next line. All right. So I guess this is all one example, so they just keep making it bigger. Or no, they are changing it a little bit. So notice that the first one that we did here, number one, was basically the equivalent of these two highlighted lines where we created them null. And then number two was the equivalent of these two lines where we created the file input stream and the scanner. And then now we're writing something slightly further on, which it says what? Assign table count. So table count equals with the first integer read from the file using, well, they were nice enough to give us the line. So we didn't even have to think of it. Okay. Output the value of table count. Okay, so that's output, they mean to the console. So system.out print line, and it says output the value of table count. Table count. All right, close the file. So we're supposed to close the file. Um, so it says attempt to access the file for testing purposes. They want us to close the file. So to close the file, if your file stream was called tablefs, you can do tablefs dot close. Or you could also do furniture stream dot close. Either of these will close the file. All right, cool. More. Okay. Iterate while shelf fs has a valid integer. So we're copying the structure from, let's say, up here, where like while something has next. So wherever we are, they already started writing it. So it says shelf s shelf fs has a valid integer. So the condition would be when shelf fs dot and you do has, like has next would mean if there's a word in there. If we want to know if it has an int, it should be have has next int or something like that. Like you can scroll up. They did use it once up here. Um, right? Like has next int is used up above. So that's how it will know if there's a valid integer to read. And then if there is a valid integer to read, we want to read it. And it says read integer shelf quantity from shelf fs. So shelf fs dot next int. So you see what's happening is we're checking with line 21 here to see if there is an integer to read. And if there is an integer to read, then we're reading it. So that's why it's shelf fs has next int and then shelf fs next int. So has next int checks if there's an integer, or next int reads the integer. All right. And then file output. which we also covered in the lab and the lecture slides. So, you can go through these. You can read file output stream constructor takes, here's the constructor. It takes a file name, a string for the file name. Given the following code, which correctly initializes outfs to enable a programmer to write to an output file.txt using printwriter's method. Okay, so this is similar to what we discussed for writing files, where it's a two-step process. I'm looking for the example here, where first you create the file output stream, and then you create the print writer. And inside of the print writer goes, in my case, it was called file stream, which was what the file output stream was called. So this variable is this variable. So they called theirs output stream. So if their file output stream is output stream, you expect to see that a new print writer with output stream inside. The print writer is required to write to a file output stream. There are other ways. Is used to allow data types other than byte arrays to be easily written to a file. Yeah, like the print writer allows us to do like print line and printf and so on. That's why we want to use the print writer. Alrighty, let's skip through here. An exception is thrown if my out file cannot be opened. Yes. Since no data is written, the code below never creates the my out file text on disk. Good question. Does this create a file? I think it does. Nope. Okay. Oh, wait. I said, does this create a file? I think it does. And so I said true, but I didn't. This actually is the opposite. Since no data is written, the code below never creates the file. No, it does create the file. When you open the file, it's going to create the file. All right. A file output stream should be closed using the close method. This might be a trick question because you can close when you open, like you're opening two things here, right? Like as an example, you're opening the file stream, or sorry, you're opening the file output stream and you're opening the print writer. And generally, you're going to close the print writer, and closing the print writer will also close the file. Um, but this says a file output stream should be closed. So it should be closed, but we normally don't close the output stream. We normally close the print writer. So it should be closed. So we say true, but we normally close the print writer. So we say false. Right. So I don't know what they want here. But they did want us to know that it should be closed. Alrighty, let's go down to challenge exercise and then we'll be done. So again, it's going to have us do this by writing the variable declarations first and then kind of work up to writing a whole file. So what do we got? Declare a file output stream named orange stream. So file, start, sorry, start, start. All right. Declare file output stream. File output stream. Named orange stream. Orange stream. Okay. And a print writer named orange writer. All right. Print writer orange writer. We could put null. That's what they told us to do last time. We don't really have to, so I don't know if it's going to require us to do that. But we did follow the instructions, and they were fine. All right. Variables, file stream, and data writer um, our file output stream and print writer, respectively. Here they are. Oops. Here. String table data name is assigned a file's name. So this is a file name. And then it says assign a file stream with a new file output stream. So again, this is the initialization. So they want us to take, we have to initialize these two variables. So for the file stream, it's a new, what is it, a new what? Well, file stream is a file output stream. So you go new file output stream. What goes in here is a file name. And they told us the file name is table data name. So that goes in there. Then you have a print writer separate. So here's the print writer called data writer. And that is a new print writer. So after you declare the file stream, then you declare the print writer. And what goes in the print writer is a file output stream. So this variable up here is what goes inside here. I tried to save that, but that doesn't work. Uh-oh, did not compile. What did we do wrong? Semicolon expected. Oh, just missing an equals there. All right, last one. All right, so this is again pretty similar to the lab that we did on this. So this time they've already created the file stream and the print writer. And remember, the whole point of the print writer is that once we've created it and it's called DIL data FS, like we'll be able to do like print, that kind of thing, or print line. So this must be telling us to do that. So let's go up here and see what they say. They say DIL quantity, blah, 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 file output stream, blah, 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 print writer, blah, blah, blah. Okay, this is what we care about. Write the following. Memo. Okay, cool. I can write memo. You do a print line and you say memo. And then we're supposed to print stars. So it's going to be exactly the same. DIL data FS, that's our print writer, print line, print the stars. And we got more. So DIL data FS dot what? Let's find out. DIL quantity, which is a variable, right? Like this. And then followed by pounds of DILs for. Okay. So we're printing with a print line, I guess. It says DIL quantity first. So you type DIL quantity. That's the variable. And then it says followed by this text, which I copied so I can paste it, followed by guest name, which is a variable, so I can just put a plus there. And then it's going to print memo, 4 stars, and then whatever this text comes out to be. And I guess that's it. And the whole point of this is that once you've set up your print writer for your file, then you just use the print writer name with your normal print methods like print, print line, printfs. Did it not work? Not all tests passed. Your program produced no output. Um, Probably we forgot to close our file. Let's see. No, data written to the file may be lost if the file is not closed, right? So we did all the writing correctly, but what I didn't do, because they didn't tell us specifically to, is close the file. And so this is a good like example. Like you will learn this sometimes. Like you're going to write a file and it won't appear, and you'll be like, well, I'm writing to the file right here. How come there's no file? And if you don't close it, there may not be the file may not be written. So we'll do that. That should fix our issue. And it does. Cool. So this was similar to the lab, although like the lab's more complicated than this. But I think that completes the entire thing. So we'll go ahead and end this video here. Um, and that will be it. So have a good winter break or summer break if you're seeing this in a future semester. I don't know.